In the previous videos, I explained the main entries of the input file, and now I want you to modify the input file based on your understanding and use Abacus to solve this model. Also, to make everything easier, I numbered the nodes and elements so it is consistent among all of us. When you're looking at this problem, you want to think about what you actually need to change in the input file. We kept the same cross-section area, and we kept the same modulus. So you need to change the node, the element, the boundary conditions, and the load condition. So now I would like you to pause this video and try to write out how you're going to change the input file and then change it in your own input file. Okay, hopefully you already have your own idea how you're going to rewrite it, so now I'm going to show you where you're going to change your input file. First, for the nodes, we're going in the order of A, B, C, and D. So in node, again, remember, for nodes, you have, because this is a 2D system, you have the first one is the number of the node. Second one is the x-axis, third one is the y-axis. So for node A, the x-axis is 5.0 and the y-axis is 10.0. You can just type in 5 and 10, it won't change in this problem. But just to keep it more accurate, you can just do 5.0 and 10.0. The second node is node B, which should be 10.0, 10.0. The third node should be point C, which is 15.0, comma 10.0. And the fourth node here is point D, which is 10.0 and 0.0. So these are the nodes. Again, these should be switched back into all of these. So after we switch out the nodes, we are going to rewrite the elements. So what is the element going to look like? Again, keep in mind the first entry of every single element is the number of the element. The second entry is the first node of that element, and the third entry is the second node of that element. So we're going to look at element 1, which is AD here. So it's element 1, and then the first node is node A, which in this case is 1. Second node is node D, which is 4. Second element is node 2 to node 4. And the third element is node 3 to node 4. Again, the element part should be switched out to here. Again, like I said earlier, the solar section here is the area, the cross-section area of the truss elements. So nothing is changed here. We don't need to change this. However, we do need to change this. So this is changing like the type of elements. You can understand as change the type of elements. So before, because we only have 2 elements, here is 1, 2. So now you should have 1, 2, 3. So this part also needs to be changed. And then the elastic part here, because the Young's modulus is not changed, so it stays the same. And then the boundary condition. The boundary condition can be harder to understand. Like I said, the boundary condition, the first entry is which node you're looking at. So we're looking at node A here, which is node 1. The second entry is which degree of freedom you're going to start with fixing. Because A is pinned, that means A cannot move in x direction, so it's first degree of freedom. However, A is also pinned. Because A is pinned, A is also fixed in y direction. So that also means it should be 1, 1, 2. Again, B is the same. So the second node is going to be fixed from x to y. The third node is going to be fixed from x to y. So here, because boundary conditions can be confusing, I want you to try another way of implementing this. So instead of implementing this, this should also equals to, if you have two entry, the first node is fixed in x and also from x to x. So this means the first node is only fixed in x direction up to x direction. And then you want it to also be fixed in y direction, so you can say the first node is also fixed from y to y. So this and the 1, 1, 2 should be interchangeable with these two lines together. So 1, 1, 1, and 1, 2, 2. You can try this out for yourself, but basically for the boundary condition, you're going to change this part. And then the next thing we need to change is the load. So for the load, keep in mind, for the load, we need the first one again is the number of node we apply the force. So in this case, because we apply it at point D, so the first is going to be 4, comma. The second one describes the direction or degree of freedom. In this case, it's pulling it down, so it's going to be in y direction, so that's second degree of freedom. And then the third one is actually the value of the force. However, you can't just put 10 to the fourth here because it's supposed to be negative force. It's supposed to be pulling down. So here you need to put negative 10 to the fourth. So again, here going back, you should change this part. So now after we change of this input file, you should be able to run this input file on your own. And for reference, the displacement in y direction at point D should be negative 5.87 times 10 to the third. So uy point D uy equals to so this is for your own reference, and the part that's due by the end of the lab is some other reading of this model. So you're going to be asked about the stress between the stress of the first element and the stress in the second element. What's the reaction force? Those type of questions. But just put the reference out here just for you to make sure your simulation is correct. Alright, that's the end of Lab 1.